Dear students, welcome to the next lecture of Inorganic Chemistry. In this lecture, we shall discuss about nitric acid. Nitric acid is a colorless liquid with melting point minus 42 degrees Celsius and boiling point 83 degrees Celsius. The density of HNO3 is 1.512 gram per centimeter cube. It is a monobasic acid with one ionizable hydrogen atom. In laboratory, nitric acid is prepared by heating sodium nitrate or potassium nitrate with concentrated sulfuric acid. The equation is NaNO3 plus H2SO4 gives HNO3 plus NaHSO4. In industry, nitric acid is manufactured by Ostwald's process. It involves three steps. Step 1 is the catalytic oxidation of ammonia by atmospheric oxygen to give nitric oxide. NH3 plus O2 gives NO. Step 2 is the oxidation of NO by atmospheric oxygen to form nitrogen dioxide. NO plus O2 gives NO2. And step 3 is the dissolution of this NO2 in water in the presence of oxygen to form nitric acid. The figure shows the reaction setup for Ostwald's process. It has three chambers. In the first chamber, ammonia is converted to nitric oxide by atmospheric oxygen. A mixture of pure ammonia and air in the ratio 1:8 under pressure is passed through chamber 1 in the presence of platinum or rhodium catalyst. And the nitric acid obtained is cooled and then fed into the oxidation chamber, chamber 2. Here it will be converted to NO2, nitrogen dioxide. And finally, the nitrogen dioxide obtained is passed through absorption tower and water is sprayed to it in the presence of oxygen to give nitric oxide. The nitric acid thus obtained is very dilute. It is concentrated up to 68% by distillation. And further dehydrated to give 98% nitric acid. The dehydration is done in the presence of concentrated sulfuric acid. And strong cooling of 98% nitric acid gives the crystals of nitric acid, which is pure, and these crystals are separated out and melted to give pure nitric acid, that is 100% anhydrous nitric acid. Coming to the properties of nitric acid, it is acidic in nature. So in aqueous medium, it exists as H3O plus NO3 minus. HNO3 reacts with bases to give corresponding salt and water. HNO3 plus NaOH gives NaNO3 and water. A 3:1 mixture of concentrated hydrochloric acid and concentrated nitric acid is called aqua regia. And what is so special about this mixture? It can even dissolve gold and platinum. The noble metals gold and platinum do not react with concentrated nitric acid, but it reacts with aqua regia, that is 3:1 mixture of concentrated hydrochloric acid and concentrated nitric acid. When these two acids are mixed together, the product obtained is NOCl plus nascent chlorine plus water. And this nascent chlorine reacts with gold to give gold chloride, auric chloride, AuCl3. AuCl3 further dissolves in HCl to give chloroauric acid. Thus, gold dissolves in aqua regia. Similarly, platinum reacts with aqua regia. Platinum plus nascent oxygen gives PtCl4, which dissolves in concentrated HCl to form chloroplatinic acid, H2PtCl4. Benzene, when treated with concentrated nitric acid in the presence of concentrated sulfuric acid, undergoes nitration to give nitrobenzene. Sucrose is oxidized by nitric acid to give oxalic acid and NO2. Nitric acid is a strong oxidizing agent, and in these oxidation reactions, the acid gets reduced to different oxides of nitrogen as well as N2 molecule or ammonium nitrate. The oxidation state of nitrogen in the product depends upon the concentration of the acid, temperature and nature of the reactant. Let us discuss a few examples. When H2S is treated with concentrated nitric acid, it is oxidized to sulfur and nitric acid is reduced to NO2. Here the oxidation state of nitrogen is +4. When H2S is treated with dilute HNO3, H2S is oxidized to sulfur and HNO3 is reduced to NO, in which the oxidation state of nitrogen is +2. Similarly, sulfur dioxide is oxidized to sulfuric acid when treated with concentrated nitric acid or dilute nitric acid. And if we are using concentrated nitric acid, the acid itself is reduced to NO2. Whereas if we are using dilute HNO3, it is reduced to NO. Ferrous salts in which iron is in +2 oxidation state is oxidized to ferric salts with iron in +3 oxidation state. When concentrated nitric acid is used, NO2 is obtained. When dilute nitric acid is used, NO is obtained. When iodine is treated with concentrated nitric acid, it is oxidized to iodic acid, HiO3, and nitric acid is reduced to NO2. When carbon is treated with HNO3, it is oxidized to carbon dioxide and HNO3 is reduced to NO2. Similarly, sulfur is oxidized to sulfuric acid and phosphorus is oxidized to phosphoric acid. When arsenic and antimony are treated with concentrated nitric acid, the corresponding oxyacids are obtained. Next is the reaction of metals which are less electropositive than hydrogen with concentrated nitric acid and dilute nitric acid. For example, if copper reacts with concentrated nitric acid, copper nitrate is obtained and nitric acid is reduced to NO2. If we use dilute nitric acid is reduced to NO. Similarly, silver reacts with concentrated nitric acid to give silver nitrate and NO2. With dilute nitric acid, it gives silver nitrate and NO. Mercury reacts with concentrated nitric acid to give mercuric nitrate and NO2. With dilute nitric acid, it gives mercurous nitrate and NO. If we consider the case of metals which are more electropositive than hydrogen, the product obtained varies with the reaction condition as well as the concentration of nitric acid. For example, zinc reacts with concentrated nitric acid to give zinc nitrate and NO2. Zinc reacts with hot dilute nitric acid to give zinc nitrate and N2O. When zinc is treated with cold dilute nitric acid, zinc nitrate and ammonium nitrite are obtained. Next comes the uses of nitric acid. Nitric acid is used in the manufacture of fertilizers. It is used in the preparation of organic nitro compounds like TNT, nitroglycerin, etc. Nitric acid is used for pickling of stainless steel. It is used as an oxidizer in rocket fuels. Nitric acid is used as a laboratory reagent in qualitative and quantitative analysis. It can be used for the purification of gold and silver.